Hello students, this is Sir Murtaza and welcome you to another lecture of physics. So let's start. First of all, we will look onto the agenda for this lecture video. So the agenda is we are going to discuss the following SLOs, and the SLOs are solve word problems related to uniformly accelerated motion using appropriate equations. Okay. So previously we have learned how to derive equations of motion and what are equations of motion. We have learned that there are three equations of motion and how we have derived it. We have learned it in our previous lecture. So now in this lecture video, we will be solving some word problems, and for those word problems, we will use the equations of motion. Okay. So with the help of equation of motion, we are going to solve the word problems. So let's start. Now, there is a question. This is a question in front of you. The question is, a car traveling at 10 ms minus 1 accelerates uniformly at 2 ms minus 2. Calculate its velocity after 5 seconds. Okay. So in this question, they are talking about a car which is traveling at 10 ms minus 1. Okay, one thing you have to remember is with the help of unit, you can define what physical quantity they are talking about. So ms minus 1 is the unit for velocity. So it means that they're talking about this velocity. Okay. Accelerates uniformly at 2 ms minus 2, and ms minus 2 is the unit for the acceleration. Calculate its velocity after 5 seconds. Okay. Now they are talking about before and after condition. So here you can easily identify that they're talking about first about initial velocity. It means that this 10 ms minus 1 is its initial velocity. Okay. Its acceleration would be 2 ms minus 2 and the time is 5 seconds. So first we have to write the data. So in the data, first, this is our initial velocity. Di represents initial velocity, which is 10 ms minus 1. Acceleration A is 2 ms minus 2. Time is 5 seconds. And what we have to find? We have to find Vf. Okay. Here they have said calculate its velocity. Okay. It means that you have to find the velocity after 5 seconds. It means that they are talking after, or you could say the final velocity. Okay. So we have to find the final velocity. Now with the help of this given data, you have to identify which formula or which equation of motion we have to use in order to solve this equation. So here Vi is given, A is given, T is given, and we have to find Vf. It means that we have to use the formula, which is the first equation of motion, which is Vf is equal to Vi plus At. Okay, then Vi is 10, plus is as it is, A is 2, and T is 5. Okay, then we will do a little maths. Now 5 multiplied by 2 is 10. Okay, and this 10 is as it is. Then what we can do, we can add 10 plus 10, which is 20. So it means that the final velocity is 20 ms minus 1. So in this way, we can find the answer for this question, in which they have asked that a car was traveling at 10 ms minus 1 and it accelerates uniformly at 2 ms minus 2. Now what we have to do, we have to find its final velocity after 5 seconds. So the final velocity is 20 ms minus 1. Okay, then question number 2. A train slows down from 80 km per hour with a uniform retardation of 2 ms minus 2. How long it will take to attain a speed of 20 km per hour? So in this question, what they have said that a train slows down from 80 km per hour with a uniform retardation of 2 ms minus 2. Okay, it means that a train is slowing down. First, its velocity is 80 kilometer per hour. Okay, here you have to identify what is this. This is kilometer per hour, and kilometer per hour is another unit for the velocity. And they have said with a uniform retardation of 2 ms minus 2. So this is retardation is another name for acceleration. So the acceleration is 2 ms minus 2. Now what they have said, how long will it take? How long will it take? It means that they're talking about the time. Okay, so they are talking about the time to attain a speed of 20 kilometer per hour. So you can say that this is its initial velocity. Okay, this is its final velocity, and this is its uniform retardation. So they have said that a train is slowing down from 80 kilometer per hour to from 20 kilometer per hour. How long will it take? It means that how much time it will take to attain its velocity from 80 to 20 kilometer per hour when it will when it will move with a uniform retardation of 2 ms minus 2. So first we will make the data. So the data is initial velocity is 80 kilometer per hour. So what we have to do, we have to change its velocity into meter per second. And in order to change kilometer per hour to meter per second, what we have to do, we have to multiply the given value by 1000 and divide it by 3600. Now by doing a little maths, we will get the answer 22.2 ms minus 2. So what just we have to do, we have to do some little maths. Okay, so 80 kilometer per hour can be written as 22.2 ms minus 1. Then vf is 20 kilometer per hour. Okay, so kilometer per hour, what we have to do, we have to multiply by 1000 and divide it by 3600. Okay, then it will change into 5.6 ms minus 1. The acceleration is 2 ms minus 2, and time is question mark. Okay, question mark means that we have to find the time. Now what we have to do, we have to use the formula. And what formula? Again we will use vf is equal to vi plus at. Okay, so with the help of this formula, what we can do, we can drive this formula. What we have to do, we have to find the value of t. Okay, so in order to find the value of t, what we can do, we can bring this vi on the other side of the equation. Okay, and this a on the other side of the equation. So this will become vf minus vi upon a. Okay, then put all the values. 5.6 minus 22.2 minus 2. Then again with the help of calculator you can find it, the time, which is 8.3 seconds. So the train which is moving which is moving uh, with 80 kilometer per hour, it will take 8.3 seconds to attain a speed of 20 kilometers per hour. So in this way we can solve this question. Now move on to the another question. Okay, this will be the last question for this lecture video. So here they have said a bicycle accelerates at 1 ms minus 2 from an initial velocity of 4 ms minus 1 for 10 seconds. Find the distance moved by it during this time interval. Okay, so in this question they are talking about a bicycle which is accelerating at 1 ms minus 2. So this is its acceleration from an initial velocity. So it means that this is its initial velocity, which is 4 ms minus 1 for 10 seconds. So this is the time. What we have to do, we have to find the distance. Okay, we have to find the distance moved by it during this time interval. So we have to find the distance which this bicycle will cover during this time interval. So first again we will find the data. So initial velocity is 4 ms minus 1. Acceleration is 1 ms minus 2. Time is 10 seconds. And distance is question mark. Now, by using second equation of motion, S is equal to VIT plus half AT square. Okay, so this is our second equation of motion. Now what we can do, we can put the values. Initial velocity is 4, time is 10, half is as it is, acceleration is 1, and again time is 10, and square as it is. Then we will do a little maths. The square of 10 is 100, and 10 multiplied by 4 is 40. Then we can cancel 2 with 100. Okay, 2 ones are 2, and 2 50s are 100. Okay, then what we can do, we can add 40 plus 50, which is 90 meter. It means that the bicycle will cover a distance of 90 meter. So in this way we will solve this question. Okay, I'm really sorry. There is one last question left. So this is question number 4. This is our last question for this lecture video. So this is question number 4. In the question number 4, they have said a car travels with a velocity of 5 ms minus 1. It then accelerates uniformly and travels a distance of 50 meter. If the velocity reached is 15 ms minus 1, find the acceleration and the time to travel this distance. So in this question, they have said a car travels with a velocity of 5 ms minus 1. So this is its velocity, okay, which is its initial velocity. It then accelerates uniformly and travels a distance of 50 meter. Okay, so this is the distance covered by the car. If the velocity reached is 15 ms minus 1, this will be its final velocity. Find the acceleration. We have to find the acceleration and the time travel and the time to travel this distance, and also we have to find the time. Okay, so in this question we have to find acceleration and we have to find the time. Now, the data is initial velocity is 5 ms minus 1, distance is 50 meters, final velocity is 15 ms minus 1. What we have to do, we have to find the acceleration and we have to find the time. Okay, then in the solution, first we will use third equation of motion. So third equation of motion is 2as is equal to vf square minus vi square. So what I have to do, I have to find the value of a with the help of this equation. So I will isolate the value of a. So this 2s will get divided on the other side of the equation. So this will become vf square minus vi square upon 2s. Now put all the values. Final velocity is 15, initial velocity is 5, 2 is as it is, and s becomes 50. Now, 225 minus 25 upon 100. Then do a little more maths, and then we will find the acceleration, which is 2 ms minus 2. Okay, so the acceleration is 2 ms minus 2. Now, by using first equation of motion, Vf is equal to Vi plus At. What I have to do, I have to find the value of t with the help of this equation. So this will become Vf minus Vi upon A. What I have done, I will bring this Vi on the other side of the equation and this acceleration also on the other side of the equation. Now put all the values. So this will become 15 minus 5 upon 2, then 10 upon 2, and the time will become 5 seconds. Okay, so in this way we'll find the time and also the acceleration. Hopefully you have understood this form. Hopefully you have understood this lecture. We'll meet you again in the next lecture video very soon. Till then, Allah.